Good morning. So the last thing we have to talk about is getting binomial expressions with radicals out of the denominator. This is called rationalizing, which again meant to make rational, which meant to make it so that there are no imperfect square roots. To make rational means no imperfect roots. Rationalizing the denominator, which is the bottom of the fraction, using conjugates. And conjugates, as you can see from this first statement here, conjugates are those binomials that differ only by one sign. Typically we do the middle sign. So x plus 4 and x minus 4 are conjugates because of the change in sign in the middle. Conjugates are not opposites, but they do have properties that we've seen before, like when we take a conjugate and we multiply them together, we get a difference of two squares, because our outer and inner terms, when we FOIL, are opposites. So what does this mean for radicals? Well, read this first statement here. If b and d are both non-negative, then if we have a radical b plus c radical d, this is a binomial. Let's just look at it. It just has two radicals. And if I take that and I have its conjugate, all I'm doing is saying the same thing with the middle sign. They differ only in the sign of one term. And one of the neat things about that is that if I multiply two conjugate radical expressions together, then the product is an integer, as we're going to see. We start by multiplying by the conjugate in the denominator, numerator and denominator, because this is the only way that I have to get rid of this 3 plus radical 5. If I do that, we start with 3 minus radical 5, 3 minus radical 5. The numerator I have to distribute. 3 times the square root of 2 minus the square root of 10. The denominator, 3 times 3 is 9. This is a difference of two squares, so it's minus radical 5 times radical 5 is 5. And then simplify. 3 times the square root of 2 minus the square root of 10 all over 4. Since I can't factor the numerator, I can't cancel anything with the 4, and I'm done. Let's try number 2. We can't rationalize by just multiplying by the radical 7, because that minus sign is just going to create this game of constantly multiplying by radical 7 and having it distribute and never getting rid of it. So what you need to look is say, okay, denominator is a binomial, two terms, there's a plus or minus, and that means that when you rationalize, you're going to have to multiply by the conjugate. So 5 plus 2 root 7, 5 plus 2 root 7. Again, distributive property in the numerator gives me 15 plus 6 root 7 over, denominator would be 25 minus 2 times 2 is 4, radical 7 times radical 7 is 7, and you get 15 plus 6 root 7 all over, this would be 25 minus 28, or negative 3. Now, if I kind of look at all of these, all of them are divisible by 3, so what I want to do is factor the numerator, take a 3 out, and I get a 5 plus 2 root 7 over negative 3. And if I simplify that, I get 3 over negative 3, which is all over negative 1. If I divide by negative 1, I can just change the sign. It's negative 5 minus 2 root 7. For number 3, it's the denominator I want rationalized. So I'm going to multiply this by 1 minus root 3. The numerator is also going to be 1 minus root 3. Now in the numerator you're going to have to FOIL. First, 2, outer, minus 2 root 3, inner, minus root 3, and last would be plus 3, over, this is a difference of two squares, so 1 minus 3. Simplify your like terms in the numerator, we get 2 plus 3 is 5, negative 2 minus 1 is negative 3, negative 3 root 3, and denominator we have negative 2. And I can't simplify this anymore because you can't factor the numerator, so that's done. Number 4, if I have 4 plus root 3, I can rationalize with 4 plus root 3. First, 4 times 3 is 12. Outer, 3 times root 3. Inner, we have 8 radical 6. And then the last would be plus 2 radical 6 times 3. All over, this would be 16 minus 3. Combine like terms, well, this can simplify. The rest can't, so I have 12 plus 3 root 3 plus 8 root 6. And if I take the two 3's out, multiply it by the 2 and get 6, left with radical 2, over 16 minus 3 is 13. Nothing in that numerator can simplify, so that's done. For number 5, we're going to want to take this radical 3 and plug it in. So we actually do a substitution now. Radical 3 squared minus 4 times radical 3 minus 8. It's taking this value and plugging it in. Because remember, that's what f of x means. It means take this, plug it into each of those spots. Well, not to the 8, but... okay, so radical 3 squared is 3 minus 4 radical 3 can't be simplified. And then minus 8. Add your like terms. 3 minus 8 is negative 5, and we still have the minus 4 radical 3. Then we have f of 2, radical 2 plus 1. So I'm actually going to take the f of x part and just rewrite it here so I can zoom in and see it. So we want to do f of radical 2 plus 1, which means to take that and substitute it in. So I have radical 2 plus 1 squared minus 4 times radical 2 plus 1 and minus 8. So that looks a little complicated, but we can do this. We are going to square this binomial, first, outer, inner, last. So first is, you can write it one more time if you need to like see it. And just go first 2, outer is plus radical 2, inner is plus radical 2, last is plus 1. Then we're going to go next step, distribute this negative 4, minus 4 radical 2, minus 4, and minus 8. Underline like terms. 2, 1, negative 4, negative 8. So that's 3, minus 4 is negative 1, minus 8 is negative 9. And then let's double underline these. Radical 2 plus radical 2 is 2 radical 2, minus 4 is negative 2 radical 2. Circle, and done. So apparently I'm on trial for murder here. Thank you, Austin. I'm in the gym lobby doing this final one. And I'm going to make these two people wait while I just do one more problem. So we have negative 2 plus radical 5 squared minus 4 times negative 2 plus radical 5 minus 8. Wouldn't you square the binomial? Yes, we have guests here with us. And I'm checking more IDs. So 4, first, outer, and last is 4. Thank you. Minus 4 radical 5 plus 5, that's foiling the binomial. Distribute the negative 4, we have positive 8 and minus 4 radical 5, and then minus 8. We could drop these parentheses now and add like terms. 4 plus 5 is 9. Then plus 8 minus 8 are going to cancel each other out, so we have 9. And then these would add to be negative 8 radical 5.
Justice doesn't wait, come on.
Yes. So apparently they need a DNA sample, so I have to finish this one pretty quickly. But they're taking it from my cheek, so that's good. Because I don't know where else. Okay, this is awkward. Squaring this, we get y minus 4 radical 3 times y minus 4 radical 3. Most of you should be able to do this without writing it out by now, but if you can, that's okay. Y squared minus 2 times 4 radical 3 times y would be 8 radical 3 y. And I would prefer putting this in parentheses as a coefficient of y rather than writing the y first, because it looks better. Then plus, this would be 16 times 3. So we have y squared minus 8 radical 3 y plus 16 times 3 is 48. And now we're done.